In this video, we will introduce how to implement query by example-based, content-based image retrieval framework in order to measure distance between a query image and each of the target images in the database. As aforementioned in the previous video, once you have implemented the distance or similarity measure, we can establish the CBIR framework. This is a typical CBIR framework. The image on the left represents a query image, and the images on the right represent a collection of images stored in the database. These images are called target images. First, primitive visual features such as color, texture, shape, and spatial location are extracted from these images. Second, the distance is measured between the query image and each target image. Then the target images are ranked in increasing order of their distance to the query image. The ranked image list is returned to the users. In this video, we will mainly focus on the process before ranking target images by their distance to the query image. To implement QBE-based CBIR framework, we create a MATLAB script and name it CBIR. The first step is that we obtain a query image and extract normalized 6-bit color code histogram count from the query image as visual feature to represent the query image. For convenience, we will define a variable string to name it import path, so that this import path will specify the path to access those images. So we use relative directory. So currently we are in the source code folder. So the dot is go to the parent, which is the project folder. And then we can go to data and then go to import. As we previously mentioned that we want this code to be used on different platforms, so we use file sep to generate a separator. Okay. Second, we want to display a dialog box to obtain the file name, okay, so that user can see the images in the directory and select one from the folder. So in order to achieve this, we use UI get file. Okay, the first parameter is the path and the file name. So the path is starting from the import path, okay, and we add a file sep, and we are only looking for all the JPEG image, so we use wildcard with the JPEG. So this will allow the dialog box to list all the JPEG image, and this function will return the name of the file. So we create a variable to hold it and we name it file name. Once we get a file name, then we can retrieve the image from the folder. Okay, so we can still use imread. Okay, and the location, actually we can use this part, import path file sep, and then we just want our file name to be. So this provides a path and a file name. Then we store the image in a variable. We name it IMQ. Q represents a query image. Okay, remember IMQ is an RGB image. So the next step is we need to convert into 6-bit color code. So we can call RGB to 6cc fast. And the input is IMQ, the RGB image, and it will return the 6-bit color-coded image. So we name the output as IM6cc and with a Q. Q represents the query. Okay. After that, we can use get his count to input the 6-bit color-coded image. And we want a 64-bit, and the intensity range is from 0 to 63. Okay. And it will return the visual features for query image. So for simplicity, we just name it lowercase q. Okay. All right. So the second step is once we already extract the visual feature from the query image, then we can load the visual feature database from the hard disk drive. So we can use the MATLAB command load. So as you can see, last time when we create a database, we save our database in the parent folder, then data, and meta, and we name it as db.mat, right? And the variable we create in the previous example is using db. Okay, so now when we load the file back, we specify the file path and which variable we want to load. So this enables us to get the variable db matrix. All right. The next steps is once we load the visual feature database into memory. So now we can allocate a matrix to store the distance between the query image and each of the target images. So we create a matrix capital D with a bunch of zeros. All right. And the number of zeros, because we want to store the distance for each query image and each target image, the query image and each target image. So the total number of distance should be equivalent to the number of rows in the DB. Okay, so for simplicity, we just measure how many rows in that. Okay, and we just need one column, so we provide the length of DB and 1. Once we create the distance matrix, so now we can compare query image to a target image. Okay. To compare a query image to a target image, we can use get distance, which we implement in the previous video. Okay, so we provide the visual factors representing the target image and the query image, P and Q. Okay, so this allowed us to get a distance. So later we are going to save the distance in the capital D. Okay, so for each target image, we need to obtain its P. So how can we get a P? So P actually is from the database, one of the row. So we retrieve the entire row, but we need to specify which row we want. All right. So in order to specify which row we want, we create a variable to hold the row index. So for simplicity, the T represents the target image. So I create a variable called a T index, TIDX, represent the target image index. Okay. So if we retrieve a P from the DB at the row T index, so when we put the distance, we also put in the same location. All right. Okay. So now we just simply create a loop to process each row. So for TIDX from 1 to length of dB. Okay, so we can indent this at the end. So we already get a D once we finish. All right. So any question? Thank you for watching the video. All right. Oh, I can add a semicolon here to prevent showing something on the comment window. All right. So in the next video, we will continue work on this script to show you how to do the remaining works. All right. Thank you. Bye-bye.